Hey guys, so this is definitely one of the toughest questions on the mock assessment, I would say, uh, and that's because this topic of lenses and mirrors is really just one of the tougher topics to understand in my personal opinion. So let's go through this scenario. We've got two scenarios given to us. One where the distance of the man and the distance of the image that he produces is both given, 1.54 meters, and then 14 centimeters in front of it. And then in the second scenario, we're being asked to determine the distance of the object or the distance of the man if he were to want to form an upright image of a chin that is twice the chin's actual size. So, in conceptually, what we need to understand is that this is a possible scenario if we were to be using a concave mirror, right? Because a concave mirror is going to give us the ability to produce virtual and real images. It's also going to be able to produce inverted and upright images, and then images with magnifications less than 1 and magnifications greater than 1, whereas a convex mirror or a diverging mirror is only going to be able to produce virtual, upright, and reduced images. So that's just conceptually what we need to understand, is that here we're using a convex mirror and not a concave mirror. But let's go ahead and go through the math of this. So what can we gain, what can we solve for to get us a step closer to the answer from the information that we're given? Well, we're given both the distance of an image and the distance of an object. So using that information, we can solve for the focal length. So we will use our if I do I die equation. So that's 1 over the focal length is equal to 1 over the distance of the object plus the distance of the image. And so the distance of the object in this case is the distance of the man, which is 1.54 meters. And the distance of the image is the inverted image that is 14 centimeters in front of it. And so that's important that it is in front of the mirror, because that demonstrates that it is a real image. So in the mirror, when you're standing in front of the mirror, if the image that you see is behind the mirror, or I guess we would think about it as within the mirror, then that is a virtual image. It's not a real image of you. But whenever that image is in front of the mirror, it's in the real world, as we would consider it, and so we would consider it a real image. And that's important because that's going to determine how we plug this value in, whether it's going to be positive or negative. And because it's in front of the mirror and it's still in the real world, then we're going to plug that in as a positive value, and we're going to put that in as 0.14 meters when we convert centimeters to meters. And so when we do that math to find the focal length, we get that the focal length is equal to 0.128 meters. So now that we've got our focal length, we can begin to worry about another part of the puzzle, and that's the magnification. We have a magnification equation that we can use to actually relate the distance of the image and the distance of the object, in this case the man's chin. So the magnification equation is as so: the distance of the image over the distance of the object. But because we're looking for a virtual image, or that is that we want an upright image on the inside of the mirror, because that's the only time we'll get a enlarged image in relation to a concave mirror, our distance for the image is going to be negative because it's going to be virtual. And we want the magnification to be equal to 2 because we want it to be twice the size. So now what we can do is we can relate the distance of the image to the distance of the object by multiplying the distance of the object on both sides. So I'm going to erase it out of here and put it over here. And we'll go ahead and take the negative sign over as well. Boom. And then so now the last step is to use the focal length, the if I do I die equation, one more time, but now plugging in the variables that we do know. So we have a new focal length. So this is the scenario what I'm drawing out. I'm drawing out the equation for the scenario of the enlarged chin. So we've got the focal length, set that equal to the distance of the object, and then plus the distance of the image. Well, we just related the I'm sorry, that should be distance of the image. So we just related that in the magnification equation, the distance of the image is equal to -2 the distance of the object. So we can actually substitute that in here. That would be negative distance of the object, -2 the distance of the object. So now what we have here is we have one like variable in the equation, and that allows us to solve for the distance of the object, which is exactly what we're looking for in the question. And so we're going to do that by using some algebra. Here is where we're going to find a common variable, and that would be by, and you know what, I'm actually going to put minus over here. It'll make it a little easier. So now what we're going to do is we're going to multiply both sides by 2 in order so that we can get a common denominator. So then we have 1 over 0.128 meters is equal to 2 over 2 dO, and that would still be minus 1 2 dO. So now we've got the common denominator. So the next step would be to subtract the fractions from one another, and that would give us 2 minus 1 over 2 dO. So that would be 1 over 2 dO, distance of the object. And then from there on, all we got to do is cross multiply. So we would cross multiply, and we get 2 dO is equal to 0.128 meters. Then we would divide both sides by the 2, and we get that the distance of the object is all in all equal to 0.064 meters. And then turning that into centimeters, we get 6.4 centimeters. So again, that was definitely one of the more tougher problems, but it is doable if you were able to do that on your own. Props to you. But it was a matter of first using the information given to find the focal length. Then if we know the magnification, we can relate both the distance of the object and the distance of the image to one another. We need to know whether we're looking at a virtual or a real image, and that's going to determine if our distance of the image is going to be negative or positive. And after doing that, we can set up the if I do I die equation with the new information given to solve for the distance of the object.